All right, Chem fam, this is Wrksht diagram worksheet number 3. Hopefully and happily trying to go through a couple example problems with you so you don't feel all alone in this cruel world. Just kidding, of course. Let's name this covalent compound first of all. There's 1 nitrogen and 3 fluorine. Since nitrogen and fluorine are both nonmetals, this is covalent. So we are going to name that nitrogen. Wow, that did not turn up right. Nitrogen. 3 fluorines makes it trifluoride. Boom. And that should be good. All right, now that we've named it, let's get down to business. Nitrogen has how many valence electrons? It is group 15, so it has 5 valence electrons. In each fluorine, there's 3 of them, have 7 valence electrons. So what does that mean? That means we have a total of 26 electrons that we have to use in order to balance everybody out. Everybody needs to be sharing or touching 8 electrons in order to be stable. Now, nitrogen's kind of our solo guy all by itself, so I'm assuming nitrogen's going to be in the middle. It's also the least electronegative, so chances are that's going to be in the center. I'm going to surround nitrogen with fluorines. And first off, I'm going to give everybody 8 electrons to begin with. What is that going to do? That's going to make everything stable, and then from there, I'm going to see if I've used enough electrons. So let's see. Just by giving everybody 8 electrons, I've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Oh, and I forgot 2 here. And that would be 26, which is how many I need. So this ended up becoming pretty straightforward. It ended up being, remember, 2 dots or electrons between elements is a single bond. So that's going to be a single bond to each fluorine with 2 lone pairs of electrons on the nitrogen and then 3 lone pairs of electrons on each fluorine, which I'll fill out. Remember, everyone has to end up getting 8 electrons after all the sharing for covalent bonding, and also you can only use the amount of electrons that you actually had to start with as valence electrons, which is 26. That one ended up being pretty straightforward. Awesome. All right, let's do another example problem. We have S2 here, which goes into a little bit of naming we aren't used to yet, but no worries about it. Let's try to do the dot diagram. First of all, each sulfur is going to have its own set of valence electrons. Since it is in group 16, they each are going to have 6, which means we have a total of 12 electrons to play with. Now, obviously, these guys are going to be bonded with at least 1 covalent bond. But if I give everybody enough electrons so that they're going to be touching 8, that's going to give me 2, 4, 6, 8, 10, 12, 14. Unfortunately, that is going to be too many electrons. So if we end up with having too many electrons and we only have 12, we need to share more. So what does that mean? It's pretty simple. It means I'm going to have to take off a pair from each sulfur, and instead I'm going to share it now in between. So now I'm going to put those dots. Let me put those in black so that doesn't confuse you. Okay? Now take a look and let's count again. You've got 2, 4, 6, 8, 10, 12. You've 12 total, and you've got 1, 2, 3, 4 pairs around sulfur, and 1, 2, 3, 4 pairs around that sulfur. So to clean that up, since you have 4 electrons being shared between the sulfurs, it's a double bond, and then you have 2 pairs of lone pairs on each sulfur. So it ends up being, again, 2, 4, 6, 8, 10, 12 electrons, which is all that we had to be able to spend. But most importantly, you have to have 2, 4, 6, 8 around this sulfur, and you have to have 2, 4, 6, 8 around that sulfur. It's like a little puzzle, and this ended up being a nice double bond. All right, hopefully that helped a little bit more, Chem fam. All right, let's try this next one, H2S2. Well, if you have 2 hydrogens, that's going to be dihydrogen, right, for 2 hydrogens, and 2 sulfurs is disulfide. All right, so we named it. That's easy. Now, let's do it. We've got 2 hydrogens and 2 sulfurs. We know each hydrogen has 1 valence electron since it's in group 1, and each sulfur has 6 valence electrons. Add that up, 6 plus 6 is 12, plus another 2 is 14 electrons. Now we know hydrogens are always stuck on the end. So I'm guessing that the sulfurs are going to be in the middle with a single bond, right? Each hydrogen we know can only have a single bond. Hydrogens can only hold 2 electrons. So we're good there. And I'm going to fill in the rest around sulfur here so that they each have 8. Now if I start counting those up, let's see, that's 2, 4, 6, 8, 10, 12, 14. Nice. I already ended up with 14. Let me just double check. Does each hydrogen have 2 electrons touching it? Good, they're happy. Does each sulfur have 8 around it? 1, 2, 3, 4 pairs is 8. Good, that sulfur's happy. And how about this sulfur? 2, 4, 6, 8. That one's happy as well. So this one ended up being a single bond to each sulfur with a single bonded hydrogen on each side. And don't forget, they each have 2 lone pairs, each sulfur on them, for a total of 14 electrons. Is everyone happy and balanced? Yes. Did you only use the proper amount of electrons? Yes. So it all works out. Hopefully this was a help for you too as well, ChemFam. All right, keep going, keep trying, work together, ask questions, and by the end of this, by next week, we should be all good. Take care.